Hello, this is Mrs. Rouse, and this is lesson 3.7, Transformations of Functions. You may remember back from maybe even pre-algebra or earlier where we've talked about transformations. So transformations include reflections, dilations, translations, and then like scale. So let's talk about them. So transformations of functions. A transformation is a change made to a graph, normally a parent function, by a horizontal or vertical shift, a reflection, or stretch or compression. So we're going to go through each of these. A vertical shift is when the graph slides up or down the y-axis. So you have your graph, it shifts up or it shifts down, whatever. Adding a constant to the original function will shift the function up or down. Example, so if I add a to my linear function, it's going to shift it up. If a is negative, it'll shift down. More examples. So if x squared is the parent quadratic function and I add 3, it shifts up. If x squared is the parent function and I subtract 5, it shifts down. So this is the now you try. Let me see. Got to get to the now you try. Oh, here we go. Okay. So this is the, let me grab a different color. I'm going to grab green. So this is the parent function, x cubed, and g of x, we're adding 4. So we're going to shift these up 4. So we have 1, 2, 3, 4. And then this will shift up 4. 1, 2, 3, 4. 1, 2, 3, 4. So this kind of looks something like this. So that's g of x. And then we have another one we're supposed to do, h of x, where we're subtracting 3. So we're taking this and we're subtracting 3. So 1, 2, 3. 1, 2, 3. 1, 2, 3. So this is going to look more like this. So that's h of x. Okay, horizontal shifts. A horizontal shift is left or right. The only thing with a horizontal shift is, be careful. The vertical shifts, if it's positive, it goes up. If it's negative, it goes down. That makes sense. Horizontal shift, if it's positive, it goes left. And if it's negative, it goes right. That is not intuitive. So we have to be careful with our horizontal shifts. For example, here's our parent quadratic. We're going to add 2 as a horizontal shift. You can see it's inside the squared. That shifts it 2 units to the left. If I subtract 4, that shifts it 4 units to the right. And here's our now you try. So let's see. Yes, sir. Okay, so this is horizontal shifts, and we know that if there's a negative, that it's going to go to the right. So let's go ahead and do g of x first. It's going to go to the right 3. So 1, 2, 3. I can't see. 1, 2, 3. 1, 2, 3. 1, 2, 3. So this is going to be g of x. And then let me check. So on this one, 1, 2, 3, 4, 5. It's going to go 5 to the, left. So 1, 2, 3, 4. Just kind of 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so this h of x. Okay. Okay. Vertical stretches. So we're stretching these or we're compressing these. And you can see that they use the absolute value as their parent function. Here we've got it multiplied by 1/3, which is going to stretch it. And here we have it multiplied by 3, which is actually going to move it in. So let's see if we can do the U try. U try. So we have our parent function here, and then we have this times 4. So what I did to try and kind of figure this out was I said, okay, so x, f of x, g of x. Okay, so let's see. When x is 1, this function is 1. And when x is 8, it's 2. When it's negative 1, it's negative 1. And when it's negative 8, it's negative 2. Okay, so now if I put g of x in front of it, I'm multiplying my answer by 4. So this is going to be 4, this is 8, this is negative 4, this is negative 8. Okay, hold on just a second. There it is. So let's go ahead and graph that. Let's see, so this is, it's going to go through 0, 0, 0, 0. And then at 1 we have 4. And then at 8 we have 8. Four, and at 8 we have negative 8. So this is going to look like that. G of x okay, and then I did the same thing here. I went ahead and multiplied by 1/2. So 1/2 multiplying this by 1/2. So that's actually no, I'm multiplying that by 1/2. So that's 1, negative 1/2, negative 1. So this is like really hard to do because it's like right here, then right there, and then right here, and then right there. Okay. All right. Let's go to the next one, horizontal stretches and compressions. The graph of y is equal to that. It says, okay, be careful. Similar to horizontal shifts, horizontal stretches and compressions act opposite. So if you're multiplying by something greater than 1, something positive, it's going to be a compression, and if it's between 0 and 1, it's going to be a stretch. Let's see what that looks like. Okay, so here we have x squared is our parent function. We multiply by 2 and it gets smaller. That's weird, right? That's suspicious. And then here we have x squared, our parent function. We multiply by 1/2 and it gets larger. Horizontal stretches and compressions using the graph of the parent function, this. So this is our U try. And I did the same thing I did on the last one. So I did x, I did f of x, and then I did g of x. Okay. So at x equals 1, f of x equals 1. And if I plug 1 in here, I get, gosh, it's 3. 3 cubed is 27. So I get 27. That's delightful. And then negative 1 is also negative 1. If I put negative 1 in here, I get negative 3, which gives me negative 27. So this looks like here, like here. It's kind of like, okay, let's change colors. And so I did this one. Now I'm going to do this one over here. So we have x, f of x, and we're going to do h of x. So I have 1, negative 1. So when I plug that in, I get 1 over, well, for the original, I get 1 and negative 1. But when I plug it in, I get 1 over 64. And negative 1 over 64 is so small. Okay, so that's 1. That's like here, and then here. Again, it's super like, oof. Okay. Okay, reflections. So we have reflections across the x-axis and reflections across the y-axis, and the way that you know which one it is. So this is my parent function. If it's negative, so g of x is equal to negative f of x, whatever. Yeah. Then it's going to reflect across the x-axis. Here, they put the negative there. So it's g of x is equal to f of negative x. You're like, it's not different, it's different, I promise. Okay. All right, let's do a now you try. All right. So I did this. I actually did this on Desmos. I went ahead and graphed this because it was a little bit harder on my calculator. Sorry. Wow. Words. Okay. And when I did that, I got this. And this was 1. And 2, 1. 4, 2. So this was like this. So that's g of x. And then this one, which should be across the y-axis, is like this. So that's h of x. So you see, this one is flipped across the x, this one is flipped across the y because of where the negative is. Absolute value function. So we have the log, and then we have, this is if we take the absolute value of anything, and then we have the absolute value of the log. You can see that the orange is the absolute value of the log. It's always going to be positive. And then the now you try. What we end up with this is this part stays the same, but when we start putting negative numbers into there, we end up with this over here. So this would be g of x. You can do this in like table form if you want to, where like I know when I put 1 in there, I get 1, negative 1, I'm going to get negative 1, 2, I'm going to get 8, negative 2, I'm going to get negative 8. That's just in the f of x, that's in the original. If I put it in here, then I get 1, 1, 8, 8, and that's how we get the other side. Activity. I think I'm going to have to make another video, but let's see. So this is, what I did was I did x, I did f of x, and then I did g of x. So I did 1, 4, and then I did negative 1, negative 4. So this is 1 and 2. And then over here, I get 1 and 2. So I end up with negative 1, 1, and negative 4, 2. So this is actually going to come over this way. And that's going to be g of x. Okay, let's change colors. Okay, so this is minus 3. So I am going to, this is going to go down 3. So 1, 2, 3, 1, 2, 3, 1, 2, 3, one side, 1, 2, 3, 1, 2, 3. So this is g of x. And I think I'm going to end there, and we'll pick up the next 2. We've got 2 more. That's it for this. I'll see you on the flip side.